Hey guys, so this is the second part of the video for evaluating functions and sequences. So in the first section of this video, we evaluated some functions, and now we're going to talk about sequences. It's kind of a different concept, so you want to kind of set aside what we were doing for functions and just kind of absorb this like it's some kind of new information. All right, so you've seen sequences since kindergarten and first grade. It's basically just a pattern of numbers. So we're going to first define an arithmetic sequence. And we have two sequences in Algebra 1. We have arithmetic and we have geometric. An arithmetic sequence is a sequence whose change, oops, I spelled whose wrong, is noted by adding or subtracting. Okay? So for example, the sequence 1, 2, 3, 4. This is an arithmetic sequence because to get from term to term, to get from the number to the next number, you're adding 1, right? This is also an arithmetic sequence, right? Because what am I doing this time? I'm subtracting 1. So an arithmetic sequence is just a sequence of numbers. Oops, I don't want to erase that one. It's just a sequence of numbers that's being either added or subtracted by something. A geometric sequence is a sequence whose change is noted by multiplication only, so no division. Okay, only multiplication. So what I mean by this is if you see that it's dividing by something, you want to flip your mind back to, hey, it's only multiplication. So a sequence or an example of a sequence of this would be 3, 6, 12, 24. Well, how are you going from term to term? What's happening as you go up? You're multiplying by 2. So this would be a geometric sequence, not an arithmetic, because you're multiplying something. All right, now, these are just big fancy words for some things that we've known our whole lives, right? We know that there's certain lists of numbers that you're adding something over and over again, or something that you're multiplying something over and over again. So they're big, spooky, scary words, but they don't have a ton of, like a large meaning. Now, common difference is related to arithmetic. So when I ask you like what the difference between these numbers are, you're like, oh, like I would add 3. So a common difference is the number being added or subtracted from term to term. So it's the number that I'm changing by each time. So for example, in that first example up here, my common difference would be positive 1 because I'm adding by 1 every time. In this example, 4, 3, 2, 1, and so on, my common difference here is negative 1 because I'm subtracting by 1 every time, okay? So the common difference is just whatever number you're either adding or subtracting. Now, the common ratio has to do with the geometric sequence. And this is going to be the number that, the number being multiplied from term to term. So for example, in the example up here, the number that I'm multiplying each time is 2. So my common ratio is 2. So remember, common ratio has to do with geometric. Common difference has to do with arithmetic. The common difference is just what you're adding or subtracting each time, and the ratio is what you're multiplying each time. Okay, so that's just a little bit of vocab there. Now this is the recursive form or the recursive rule. I want you to take a look. So again, we have two types of sequences, arithmetic and geometric. Now, if you look at their forms, they're exactly the same. What's the only difference we see here? Okay, the only difference we see is this back part, right? Everything else is exactly the same. It's just that those two things are different. Now I'm going to go ahead and define some of these things so that we kind of know what these things mean. So the A of 1. So remember when we read with parentheses, right? Like this is f of x. So I would read this as a of 1. Well, a of 1 means the first term. And it means the first term in both sequences. So what do you think a of 3 might mean? This would mean the third term. Okay? And a of 7 would be the 7th term. So whatever number is in there, that's the term number. So if I'm asked to find a of 5, I'm asked to find the 5th term. So again, it's just not that it's super hard to understand. It's more like when you look at it for the first time, it looks a lot scarier than it actually is. So a of 1 means the first term, and so on. Okay, now this first part in the front, a of n, is any term, or it's sometimes the term we're looking for. So term, yeah, let's just call it the any term. This can be literally any term. Okay, and it would mean the same thing in the geometric sequence. Typically, it is the term we're looking for, but it could really be any term. N can be any number, right? I can have a of 7, a of 3, a of 15. So n can be any term, any number. Okay? Well, here I have a of n minus 1. And I have a of n minus 1 in the geometric as well. This is the previous term. Okay, this is basically the term before. And now the only difference we have here is that for arithmetic, we have plus d. Well, if you think about it, what are you adding and subtracting by in the arithmetic sequence? The common difference. That's the number that you're either adding or subtracting from term to term. So this is going to represent the common difference. Okay? And the r is going to represent the common ratio. It's whatever number you're multiplying by to get from term to term. So again, these forms are exactly the same, except that the only thing that's different is the very end. Okay? So I'm going to move on. So before we even go into practicing even using these, let's actually just see if we can figure out which sequences are arithmetic versus geometric. So are the following sequences arithmetic or geometric, and what is a common difference / common ratio? So again, common difference is associated with arithmetic, and common ratio is associated with geometric. So if we're starting with number 1, I have 2, 4, 6, and 8. Would this be arithmetic or geometric? This is arithmetic, because how am I getting from term to term? I'm adding 2 each time, right? I'm adding the same number. I'm adding 2. So this is going to be arithmetic. And my common, now what would I have here? Would I have a difference or a ratio? I would have a difference. So the common difference, sometimes I like to put CD for short. The common difference here is 2, positive 2. Okay, now the next one, 5, 10, 15, 20. What do you think this is? Well, how are we getting from number to number? Think about that. You're adding 5 each time. So if I'm adding or subtracting, I have an arithmetic sequence. Okay? So if it's arithmetic, then I have a common difference. And again, if you want to just shorthand it by writing CD, you can also do that. My common difference here is positive 5. All right, moving on to number 3. Now here I have negative 1, 1, negative 1, 1. Well, I notice that my signs are flip-flopping backwards, but my number isn't changing. So what's happening here? Well, that must mean I'm multiplying because I'm obviously not adding. I can't add and subtract. I can only do 1. Well, what times negative 1 makes 1? If I multiply by negative 1. 1 times negative 1 is what? Negative 1. What's negative 1 times negative 1? Positive 1. So I'm basically multiplying by negative 1. Anytime you see the signs flip-flopping back and forth between positive and negative, that means there's a multiplication in play with a negative. So if there's negative signs going back and forth, then that means that, oh gosh, I'm multiplying by something that's negative. Okay, so if I'm multiplying, this means that I have a geometric sequence. If I'm multiplying something. Okay, so that means that I would have a common ratio. And my common ratio here would be -1 because that's the number I'm multiplying by each time. Okay, lastly, I have 20, 10, 5, and 2.5. Now, I notice that my numbers are going down, but they're not going down by adding or subtracting. I'm actually dividing by 2. But at the very beginning, we said there's no such thing as division. So what do I have here? Well, if there's no such thing as division, I got to find a way to say that this is multiplication. Well, if I'm dividing by 2, what's actually happening here? I'm multiplying by 1/2, right? If I'm dividing by 3, what do I multiply by? 1/3. If I'm dividing by 5 from term to term, I'm actually multiplying by 1/5. So what do you notice is happening as I go down here? I'm dividing by 2. But again, we can't say division, we got to say multiplication. So we're multiplying by 1/2. Or 0.5 if that's what we want to write. You can also write 0.5. So this is a geometric sequence. And our common ratio, not difference, is 1/2. Or you can put 0.5, only because that's a nice number and I'm okay with that. So if you want to just have this little note on the side to remind you that there's no such thing as division, you want to remember, hey, I'm multiplying by something. So if you see it's dividing by 2, you want to actually put multiplying by 1/2. If you see it dividing by 4, you would multiply by 1/4. Okay, so that's just basically recognizing if a sequence is arithmetic versus geometric. All right, so in the next 4 examples, we're going to look at using the recursive rule and then applying the rule. So in the first one, if a of 1 equals 7, and the recursive formula is a of n equals a of n minus 1 plus 4, find the next 3 terms. All right, well, they gave us 2 bits of information here. They told us that a of 1 equals 7. Well, remember, what does a of 1 mean? It means the first term. A of 3 means the third term. A of 8 means the 8th term. So they told us what the very first term in our sequence is. So for example, the first term in the number 1 here is 2. So they're telling us that the very first number that we have is 7. So the first term is 7, okay? And then it gives us the recursive formula. A of n equals a of n minus 1, or plus 4, or a of n minus 1 plus 4. Now, I said that all of the formulas look exactly the same. The only difference is that very back part, right? So if I look at both of these formulas, they're exactly the same, and they're always going to look like that except for this very, very last part back here. So it's telling us plus 4. That tells us what's happening from term to term. So I know that I'm going to be adding 4. And you're like, I don't understand what this formula even means. Remember, this is the previous term. So if I take the previous term and I add 4 to it, I'll get the next term, okay? So let's try this out. It's going to take some getting used to. It's much easier than it looks, okay? If they gave me the first term already, then the next term I would find is the second term. So that would be a of 2. Okay, well, how do I find the second term? Well, I know that I'm adding 4 to get from term to term. The first term is 7. Okay, so how would I get the next one? I would add 4 to it, and I would get 11. Okay, so what am I doing? I'm taking the previous term, in this case it's 7, I'm taking the previous one and I'm adding 4 to it, and I get 11. That's how we're using this here. Okay, well, it says I need to find the next 3 terms, so I have to find 2 more. I have to find the third term, and I have to find the fourth term. Again, why am I finding these 3 terms? Because it wants me to find the next 3 terms, right? If you have your answer look like this, you didn't find the next 3 terms, you found the first 3 terms. So make sure you're reading to see what the problem asks you to find. Okay, well, how do I find the third term? Well, I have to take the previous term and add 4 to it. Well, what was the previous term? 11. So I'd add 4 to it and I get 15. So how am I getting from number to number? I'm adding 4. You want to make sure we're using this notation here. I don't want to just list the numbers, right? I want to specifically say the second term is 11, the third term is 15, and the fourth term would be 19, because I take the previous term, which is 15, and I add 4 to it. So did I find the next 3 terms? I did. So that means I'm done. Okay? So again, the formula is there just to tell you, hey, this is what's happening as I go from term to term. And it's just going to take a lot of practice to get used to the way it looks. But here's what's actually happening. And this is just a side example. It's not to do with the problem, but I'm just saying, hey, let's see something. Okay, so this is the form that they gave me, right? This is the recursive rule they gave me. Well, let's say I want to find the fifth term. If I want to find the fifth term, that's going to be a of 5, correct? So the n became a 5. Do we see that? So n can be any number. And so I'm going to pick 5 because I want to find the fifth term. So let's test this out. So that means that n is now 5. Okay. Well, I can simplify this. Well, I have a of 5 equals, what's 5 minus 1? 4. Right? 5 minus 1 is 4. Well, do I know what a of 4 means? A of 4 means the fourth term. Well, what was the fourth term? It was 19. So I would take the previous term, which is the fourth term, and do 19 plus 4, and what's that equal? 23. So the fifth term is 23. Now, would it have just been easier for me to take 19 and just add 4 to it and get 23? Yes, it would have been way easier to just do that. But I wanted to show you what the formula is doing. So the formula is saying take the previous term, which is the fourth term, add 4 to it to get the fifth term. So to get the seventh term, I would have to take the sixth term, add 4 to it to get the seventh term. If I wanted the 11th term, right? If I wanted the 11th, I would take the previous, which was the 10th, and add 4 to it. So that's what the rule is saying you're doing here. Okay. Again, that's just a side note. I don't expect you to use the formula that way, but I do expect you to interpret it. Okay, the next one. If a of 1 equals 3, and the recursive formula is a of n equals a of n minus 1 times negative 2, find the fourth term. Now here, I'm asked to find the fourth term. I'm not asked to find the next 3 terms. I just want the fourth only. So the first bit of information they gave me was that a of 1 equals 3. They gave me that first term. They told me what my sequence starts with. Now, they gave me the recursive rule as well. A of n equals a of n minus 1 times negative 2. But the only thing that's super important here is that very last part, because everything else is always the same. It's telling me that to get from term to term, I'm going to multiply by negative 2. Well, they already gave me the first term, which is 3. Okay, so let's find the second term. How would I get the second term? Well, I would take the previous term and multiply it by negative 2. 3 times negative 2 is negative 6. How would I get the third term? I would take the previous term, which is negative 6, multiply that by negative 2, and I get positive 12, because a negative times a negative is a positive. Okay, the next thing I would do, sorry, I'm going to match this with what's happening here. I'm going to find the fourth term. Now, when do I stop? Well, I know I have to stop at the fourth term, so I know this is going to be my last step. I don't want to keep going and wasting my time, right? So to find the fourth term, I would take the previous term and multiply it by negative 2. 12 times negative 2 is negative 24. Now, what would I box as my answer here? Well, I would only box this last section because it wants me to find the fourth term. Well, what happens if they want me to find the sixth term? Well, then I would keep going until I got to the sixth one, and that's the one that I would box. So we do want to use a bit of function notation. Function notation is basically using the a of 4 at the very beginning. So you're telling me that you're using the fourth term here. All right, in the next two, it's kind of different. So we're asked to be given the sequence, or we're given the sequence, and we're asked to write the recursive definition or the recursive rule. Well, if I just look at this sequence, I have 20, 15, 10, and 5. What's happening to my sequence? Well, the numbers are going down by 5. So I know that this is arithmetic, right? Because I'm subtracting. My common difference here is negative 5. I'm subtracting by 5 as I'm going down. Well, remember, the recursive rule looks the same for both except for the very last part. So you'll have either plus d, or you'll have a of n equals a of n minus 1 times r. So again, they have two types, either arithmetic or geometric. Well, since I know this is arithmetic, I'm going to use this first one. Okay, so I have a of n equals a of n minus 1. And what's happening as I go from term to term? I'm subtracting 5. And that's all I'm doing. The a of n and the a of n minus 1, again, is the same in every recursive definition. Okay, that's just the name of it, is recursive. Recursive basically means you're using the last term to help you. So recursive doesn't have a super special meaning to it. It's basically just what's happening here, is you're taking the previous and you're doing something to it. Okay. Looking at the very, very last one, given the sequence 1, -3, 9, and this should be -27. I have a little typo there. 1, -3, 9, -27, write the recursive definition. Okay, well, what's happening as I go from term to term? Well, it doesn't look like I'm adding anything because my signs are going back and forth, which means I'm multiplying by something. So if I'm multiplying, it's geometric. Okay, so if it's geometric, I have a common ratio. Well, what's the number being multiplied as I go from term to term? -3. 1 times -3 is -3. -3 times -3 is 9. 9 times -3 is -27, and so on. So if it's geometric, I'm going to use the second one. Again, this formula looks the same for all types of sequences except for the very last part. So what am I doing to get from term to term? Am I subtracting 3? I'm multiplying by -3. So make sure you have a multiplication symbol in there. All right, so that is it for the notes over sequences. If you have any questions, just please feel free to reach out.